Hey everybody, and welcome to Part C, Community Relationships. Now you might be wondering, didn't we just cover Part C and that was something else? Yes, we did. This is a horrible typo and we don't have enough time to change it, so we're doing C twice. C? C. So community relationships is referring to symbiosis, those close relationships between members of different species. Now, in a lot of these things you've been taught, like, between humans, like you and your friend have a predation or parasitism, hopefully not a predation, that means you're eating your friend, but a parasitic relationship or you're competing and stuff like that. But really, when we're talking about symbiosis from a biological perspective, we're talking about between two different species. So, while you and your friend may have a mutualistic relationship, that's not really a technical mutualism. That's just you and your friend getting along and helping each other out. So if it was between you and your dog, that would be mutualism. So predation is when one organism kills and eats another one for food, and so that second organism dies. We usually refer to this as a plus-minus relationship. So you can see that little goby inside the lizardfish. He is not having a good day. Over time, our predators have evolved in response to the prey, and the prey have evolved in response to the predators. So as the prey gets better at hiding, the predators get better at hunting. As the prey gets better at hunting, the prey gets better at running. So, yeah, I'm tongue-tied. It's so complicated. But we call that coevolution. So they're evolving in response to the other. So, spider webs, the size and the shape and the strength of the webbing. The spiders with the bigger, better webs were bigger, better catchers, but the flies that can fly through those little spaces, they live longer, we make more babies and pass those genes on. Tigers with stripes hide a lot better, they can sneak up on the prey and eat a lot more, and they get big and fat and make lots of babies and pass those genes on too. The prey, the more it evades, the more babies it can have and the more it can pass those genes on. So mimicry, looking like other ones, and especially those that are toxic, help them survive. Plant toxins, those hot chili peppers or the oils that you get in a mint, they're actually meant to deter insects from eating. And so those plants that are nice and hot and spicy, they tend to live longer, make more babies, and we see those genes passing on. There's a couple YouTube links there to give you some more examples, and I'll post those on the website. If you can't, click them here. So here's a couple more examples. We got ladybugs. They're I know they're so cute, but they're actually like some mean little predators. If you're an aphid, a little tiny insect that feeds upon the phloem of plants, a ladybug is your worst nightmare. Praying mantises, not only do they chop the heads off their lovers, but they also eat like cute little hummingbirds, as you can see in the picture. And then, of course, the Venus flytrap. Now, flytraps, they also do photosynthesis. They are kind of autotrophic, but if they're in their natural habitat, the soil tends to be pretty nutrient poor, so they also have to take in a nitrogen source, and insects happen to be a great one. Parasites, similar to predator-prey, they do have a plus-minus relationship, but in this case, the parasite lives or lets the host live longer. If the host dies, so does the parasite. And so all those little things that make you kind of creepy, crawly ticks and tapeworms and fleas and all that, they're wanting to feed on you, but keep you alive long enough that they can eat for quite a while. And so here's an example of heartworm. If you ever have any pets, they usually have a little worm or a little food that you can give them. It's killing off these nasty worms that'll take up residence in their cardiovascular system. And so that parasite has to quickly find another host or it'll die as well. And so they usually have some complex life cycles. And so here's roundworms. They cause different diseases: ascaris, hookworm, pinworms, strongyloidiasis, trichinosis, whipworm disease. They will live, and they usually pass their eggs out through the fecal material, and then an organism such as a human, more commonly dogs and cats, they'll come in contact with those eggs that passed out through the fecal material. By fecal, I mean poop, by the way, and they'll get them in their system, which is why washing your hands is incredibly important. You don't want to get them having taking residence up inside your body. So here's hookworm too. Again, passes out through fecal material. We tend to see these more in underdeveloped countries with poor sanitation systems because people come more in contact with the parasite. Here in the United States, we're pretty clean, and we're really diligent about washing hands and keeping the sanitation system in check. Not only do you have those weird little parasites that live inside you, we also have large-scale parasitism. And so here we have the brown-headed cowbirds. Now these guys are mean because what they do is they don't take care of their own kids. They dump them on other birds. And so they will go and fly to a nest and lay an egg in another bird's nest. And then the mom and dad go away and go about their business. In the meantime, that bird that was in that nest normally, he sees this egg, and they're not very bright. They'll sit on that egg and they'll hatch it, and then they'll hatch their own little chicks. Their own little chicks, though, can't stand this big bird. The cowbird actually has an adaptation where it will go and push out the baby birds from the other bird, and so knocks them out of the nest. And then this mama bird is like, wow, this is the biggest baby I've ever had. Well, let me keep feeding him, and they take care of him. And so the cowbirds end up passing on. Now, the downside to this parasite is it lowers the population of songbirds, because those are the nests that usually lays in. And so we see the population shifting a little bit when cowbirds are involved. Competition is where both organisms are harmed by the interaction because they're trying to use the same resources. And so we see competition like if they're fighting over a water source and butting heads on that, or if they're fighting over a particular food, they kind of beat each other up, and it's negative. Mutualism is the one we all love. It's the happy one, where both organisms benefit from the relationship. The most common one we talk about here is insects and flowering plants, because the insects go and they get the pollen on their body, and they get to feed. That's their benefit. And then when they go to the next plant, they pass that pollen onto it. And so the plant gets pollinated, the bee gets lunch, everybody wins. So we got a link here for how E. coli actually has a mutualistic relationship with you. We give it a bad name when it gets into the bad spots in our body, but you have probably more bacterial cells than human cells in your body, and a lot of that's due to the E. coli living in your large intestine. Lichens are another example here. This is a relationship between a fungus and an algae. Fungi don't normally photosynthesize, and algae does. And so, but algae needs an aquatic, nice, warm, moist environment. And so there's somehow through time they formed a little relationship, and now the algae can reside inside the fungus, so they can be on land. In exchange, they do photosynthesis and feed the fungus. Also, cleaner fish in the ocean. If you saw Finding Nemo, that's the little Jacques the shrimp. They will go and clean off and eat the parasites. They love the parasites. They're delicious and tasty. And the larger organism gets cleaned and doesn't have to worry about the parasites. So it's a win-win. Commensalism is one we don't see very often. It's kind of hard to find examples for it, but one organism benefits and the other is neutral, not helped or harmed. And so here with the clownfish and sea anemone, the clownfish gets protection from the sea anemone. The sea anemone really just, it doesn't get anything out of the deal. Sea anemones will do just fine with a clownfish. They'll do just fine without a clownfish. And so there's really no benefit, but it's not harmed either. And so that's a commensalism, or sometimes they'll be called commensalistic relationship. Another one there are barnacles, and so barnacles are little crustaceans that will take residence on surfaces. So you see the poor gentleman on the right, by the way, that's makeup, that's Hollywood. But the barnacles will live like on the skin of a whale, and they'll just feed off the ocean stuff. It doesn't hurt the whale, doesn't harm it, no big deal for the whale, but the barnacles get a free ride, and so they get access to more food. So here's a couple situations. Let's see how you do. Match each situation with the correct type of symbiosis and provide a reason for your choice. So here in situation 1, the mycelium of a mycorrhizal fungi attaches to the root system of a tree, thereby increasing the surface area of the roots. The tree in return provides the mycelium excess sugars. Pause and think about it. All right, so what'd you come up with? Well, the helps the plant get water and in return gets food. That's plus plus. That is mutualism. Part 2, raspberry seeds are unaffected by the acids and enzymes of animal digestive tracts. Birds that feed on the nutritious raspberry excrete, poop out, the raspberry seeds in a location other than the original raspberry bush. And so the seeds are unaffected. The bird gets the food. Let's see. Pause it and think about it. Welcome back. So what did you come up with? Hopefully you saw that the seeds go to a new place. The bird gets nutrition. That's a plus plus. That is mutualism. Situation 3, tapeworms live in the digestive tract of many animals and eat most of the nutrients entering the digestive system before the host animal can absorb any of it. Think about it for a second. All right, so what'd you come up with? Hopefully you said it is a parasite. It actually takes away the nutrients from the host. In exchange, it gets large and fat and happy. And so, believe it or not, they actually used to use this for a diet aid. They would sell people these eggs. They put them, they'd swallow them. The tapeworm would live in the stomach and eat all off the food, and the person would lose weight. Although they'd also be really sick, and the tapeworm would do horrible, horrible damage. Hey, you're skinny. Awesome. All right, situation 4. The clownfish often hide in the tentacles of a sea anemone. The clownfish produces a mucus preventing them from being paralyzed by the sting of a sea anemone tentacle. The sea anemone is unaffected by the presence of the clownfish. Well, were you paying attention? We just talked about this one. You better have put commensalism on your paper. Come on. All right, that concludes Part C. Part C2, I guess. And now we're going to go on to Part D.